Scientific notation. So there are two ways to write numbers. There's standard notation and what we call scientific notation. Standard notation, you're used to it. If I write a number 100, 200, 300, all these, 2, 4, 5, 6 is called standard notation. Scientific notation is a useful method of writing numbers that are too large or small to write conveniently in standard notation. It's generally expressed as a digit number between 1 and 10 and multiplied by a power of 10 so that we can get back to that number in standard notation if we wanted to. So this is because the way that we work in chemistry and in other sciences is sometimes we measure things that are very small. An atom is very, very small, but we still measure it. And to describe the smallness of it, if we use standard notation, would be kind of really very, very hard to do and hard to say out loud. Here's an example. A mole measures how many atoms there are, and notice there's a lot of atoms here. So if I was to say this number and write it out all the time, if I'm writing it to other scientists or doing something like that, it would take forever. So what scientific notation does is write it as a digit number between 1 and 10, so 6.022, which is these numbers right here. It takes those numbers and actually makes it a decimal, 6.022 times 10 to the 23rd. So what that means is that I would multiply this number by 10 to the 23rd power, and that's going to move the decimal place 23 places to the right because it's positive. This exponent is positive. So because the exponent is positive, that means the decimal point that's located here that we put here is going to move 23 spaces and going to recreate this number. And if it was written with a negative, that means the decimal point would go in the other direction, in the opposite direction, to make something smaller. That's how we would usually describe something that's very, very, very small. We would put a negative exponent, meaning we actually divide by a power of 10. We divide that number by a power of 10. So when we want to write a big or a too large or too small number, we write them in scientific notation because it would not be as convenient to write them in standard notation. So we have to be able to convert back and forth between scientific notation and standard notation so that we can understand how really big something is or how really, really small something is. And so we can get a sense of when we multiply by a power of 10 here, we have a positive exponent, but when we move the decimal point, if we're trying to move the decimal point in another direction to the left, we have a negative exponent, which just means that you're actually dividing by a power of 10. So we have to be able to do both of these and transfer standard notation and scientific notation. And in doing so, we will be better able to do problems that involve large number of atoms that are converted to moles and be able to use that information in many different ways in science.